In last video, we discussed the notion of finding critical points. So we discussed that critical points are the points on the graph of a function where the derivative is either equal to 0 or it is not defined. And these critical points are very useful since critical points can be used to find local maximum and minimum points, and every local minimum and maximum point is a critical point. But also it is very important to note that not every critical point is a local maximum or minimum point. So in this video I'm interested if we can find a mathematical definition in order to differentiate when when a point is either a local minimum or a local maximum. Because as you can see from the graph, it is very easy to find the critical points, and if you have the graph sketched, you can actually eyeball whether it is a local minimum or local maximum. But I'm interested to see if we can use our knowledge of derivatives in order to find a little bit more, a more mathematical way in order to prove this. So let's say we have a coordinate system here, and we have a function something like this, and around here this is the point C. Now obviously this is a maximum point, a local maximum point, since the value f of c, this is f of c is bigger than any other value f of x in the domain. But what can we notice now? On the left side we can see that the slope of the function is positive, which means that the derivative of the function on the left side of this interval, on the left side of the point C, is negative. So we can say when x is smaller than c, the derivative is positive. And what about on the right side of this point C? Well, we can see that the derivative is negative. So when x is bigger than c, the derivative is negative. So this is very interesting. We can see that a local maximum point is any point for which the derivative changes sign from positive, so from positive to negative. Now what about local minimum points? Let's see about that. We have a function something like this, f of x, and this is the point c. What can we say about the derivative of this function? Well, on the left side the derivative is negative, or the slope is negative, so we can say when x is smaller than c, f of x is negative, and when x is bigger than c, we can see that the derivative on the right side of the point c on this interval is positive. So when x is bigger than c, f of x is bigger than 0. So that's very interesting. A local minimum point is any point at which, of course, it is a critical point, since here the derivative f of c is equal to 0. The same case is for the maximum point, but here the local minimum point is the point at which the derivative of the function changes sign from negative to positive. The same can be said, for instance, we can apply the same notion if we have a function that goes something like this. Here, this is the critical point, since the derivative f of c is equal to 0. But it is not a local maximum or minimum point. Why? Well, we can see that the derivative does not change sign. The function is always increasing. Now when a function is increasing, as you can see here, the derivative f prime of x is bigger than 0. So the derivative actually does not change its sign, and that's an indication that this is not a local minimum or maximum point, even though it is a critical point. So the important thing to note here is that the derivative shows us when the function is increasing or decreasing, and it can be used to find local minimum or maximum points. Okay, I think we have a little bit of time to solve an example. I'm going to be very quick. So we have the function f of x is equal to, let's see, x to the power of 3 minus 3x squared minus 9x plus 6. We need to find the local minimum and maximum points. Okay, so first we find the derivative. 3x squared minus 6x minus 9. So this is a quadratic equation, and this needs to be either undefined or 0, since we're looking for critical points. And since it is a continuous function, this cannot be undefined, so we need to find the zeros. So I think that we can factor out a3. So minus 2x minus 3 is equal to 0. And let's see, if we factor this, we'll get what? X minus 3 times x plus 1 is equal to 0. So the zeros are x is equal to 3 and x is equal to minus 1. So these are the critical points, and if you want to graph this, this is minus 1, let's say, and this is 3. Okay. So these are the critical points. This is just the graph of this function here, the derivative function. So we can see that at the point minus 1, what can we say about the derivative? Well, it goes from positive. Remember, this is the function f prime of x. This is not f of x. So we're looking for the sign of derivative, not if the function is increasing or decreasing. The sign here tells us that the function is increasing, since it is positive. And here on the right side of the point minus 1, we can see that the derivative is negative. Now what does that tell us? Well, if I can find, this is the negative, and where is it? Here it is. You can see that the derivative goes from positive to negative. So this is a maximum point, and here we can see the same thing. It goes from positive to negative. And here, on this part of the function, it goes from negative to positive, so this is a minimum point. So minus 1 is a local maximum point, and 3 is a minimum point, according to the definitions that we have just provided.